Ever wondered how the air on other planets might be? How exotic their skies could appear? Welcome to the mesmerizing world of exoplanet atmospheres. Exoplanets, the celestial bodies orbiting stars outside our solar system, are a hotbed of galactic intrigue. Their atmospheres, teeming with mysteries, hold the key to understanding the possibilities of life beyond Earth. From the detection of water vapor to the presence of precious metals, these atmospheres are as diverse as they are enchanting. The study of these unique environments not only broadens our knowledge of the universe, but also opens up a Pandora's box of questions about habitability. Can these planets support life? What do their unusual chemical compositions tell us? And most importantly, are we alone in this vast cosmos? These are the intriguing questions that drive scientists to probe deeper into the enigma of exoplanet atmospheres. So prepare yourself as we embark on a journey to unravel the top 10 mysteries of exoplanet atmospheres. At number 10, we have the surprising absence of water vapor in some exoplanet atmospheres. Now, one might think water vapor would be a given in certain exoplanets, especially those residing in the habitable zone of their stars, that Goldilocks region where conditions are just right. Not too hot, not too cold, but just right for water to exist in its liquid state and consequently as vapor in the atmosphere. However, our space telescopes sometimes tell us a different story. They peer into the distant cosmos, analyzing the faint light of these distant worlds as it filters through their atmospheres. And sometimes, against all our expectations, the signature of water vapor is conspicuously absent. But why? Well, there's no one-size-fits-all answer. It could be that the water is hidden beneath a layer of clouds. It could be that the planet's temperature is too extreme, causing the water to either freeze out or boil away. Or perhaps the water is there, but our current detection methods just aren't sensitive enough to spot it. These are just a few theories, but the truth is, we're still trying to figure it out. Each exoplanet is a unique world with its own set of atmospheric conditions and characteristics, and that's what makes this field so fascinating. So the lack of water vapor, an essential ingredient for life as we know it, remains one of the intriguing mysteries of exoplanet atmospheres. Number 9 presents us with the enigma of exotic clouds in exoplanet atmospheres. You might think of clouds as white, fluffy collections of water vapor, but in the atmospheres of distant exoplanets, things can get a little more, well, exotic. The clouds found in these alien skies aren't composed of water, but of substances that might seem out of place in a cloud, at least to our Earth-centric perspectives. Take, for instance, the exoplanet known as HD 189733b. This far-off world, located 63 light-years away from us, is believed to have clouds made of silicate particles. In layman's terms, that's essentially glass. Imagine that, clouds of glass shimmering in the alien sky. Then there's WASP-31b, a gas giant nearly half again as large as Jupiter. This exoplanet has an atmosphere filled with clouds of potassium chloride. To us, that's a compound commonly used in fertilizers and as a salt substitute. The formation of these exotic clouds is a fascinating process, one that involves high temperatures, intense atmospheric pressure, and unusual chemical reactions. The implications of their existence are equally intriguing. They offer unique insights into the atmospheric conditions and chemical compositions of these distant worlds, offering us a glimpse into the remarkable diversity of the universe. These exotic clouds certainly add a touch of mystery to the study of exoplanet atmospheres. Coming in at number 8, we have the unusual chemical compositions found in some exoplanet atmospheres. What makes these compositions so intriguing is that they're not what we typically expect to find. These exoplanets, located light-years away from us, have atmospheres teeming with chemicals that have left scientists scratching their heads. For instance, consider the exoplanet WASP-12b. This gas giant has an atmosphere abundant in carbon monoxide, a compound rarely detected in such high quantities in other exoplanet atmospheres. This unusual abundance is most likely due to the extreme heat of the planet, which breaks down water molecules, leaving behind an abundance of carbon monoxide. Or take the case of HD 209458b, also known as Osiris. This exoplanet's atmosphere has revealed the presence of sodium, a chemical element not typically associated with the atmospheres of gas giants. The detection of sodium here suggests that the planet's atmosphere is being eroded and escaping into space. These unexpected chemical compositions are not merely curiosities. They provide us with invaluable insights into the conditions on these distant worlds and help us better understand the processes that lead to the formation and evolution of planetary atmospheres. Each new discovery, each unexpected chemical detected, brings us a step closer to unraveling the mysteries of these distant celestial bodies. The discovery of these unexpected chemicals certainly adds to the complexity and mystery of exoplanet atmospheres. At number 7, we have the extraordinary temperature extremes in some exoplanet atmospheres. Now let's dive into the fiery depths of some of the most extreme environments in the universe. The extreme temperature variations observed in some exoplanets have sparked a myriad of questions. How can an atmosphere exist in such conditions? How does it affect the planetary environment? And what does it tell us about these far-off worlds? These are not your average everyday temperature swings. We're talking about differences that could turn lead into a puddle or freeze nitrogen solid. Imagine a world where the day side is so hot that metals like iron and nickel would vaporize, only to condense again on the cooler night side. This is not the plot of a science fiction novel. This is the reality on some known exoplanets. Scientists believe these extreme temperature variations could be due to the proximity of these exoplanets to their stars, with some orbiting so close that they're practically skimming the surface. This results in scorching temperatures on the star-facing side and freezing conditions on the other. These temperature extremes can result in some truly bizarre atmospheric conditions. For instance, the intense heat could cause unusual chemical reactions, creating exotic compounds and causing the atmosphere to behave in ways that defy our current understanding. So, as we venture into the study of these alien worlds, we're not just exploring new planets, but new physics too. These temperature extremes pose a fascinating mystery in the study of exoplanet atmospheres. Number 6 brings us to the intriguing presence of precious metals in some exoplanet atmospheres. Yes, you heard that right. Precious metals like gold and platinum have been detected in the atmospheres of distant worlds. Now, the idea of a planet with an atmosphere glittering with particles of gold or platinum might sound like something out of a science fiction novel, but the reality is even more fascinating. The detection of these precious metals in exoplanet atmospheres is not just an interesting fact, but it also has profound implications for our understanding of these distant worlds. You see, the presence of these metals suggests that the planet has undergone intense geological activity, possibly including volcanic eruptions that have propelled these metals into the atmosphere. In other words, this could be a sign of a highly dynamic and active planet. Moreover, the presence of these precious metals also sheds light on the planet's formation and evolution. These metals are typically formed in the core of a planet, so their presence in the atmosphere suggests that the planet has experienced some serious upheavals in its past. On a more speculative note, the presence of gold and platinum in an exoplanet's atmosphere could potentially make these worlds targets for future space mining operations. Imagine a future where we traverse the stars in search of precious metals. The presence of these precious metals certainly adds a golden touch to the mysteries of exoplanet atmospheres. Halfway through our countdown at number 5, we have the mystery of supersonic winds in exoplanet atmospheres. Winds are a common feature in planetary atmospheres, but on some exoplanets, they reach speeds that would be unthinkable here on Earth. We're talking about winds that can travel at more than 5 times the speed of sound. Imagine a gust of wind so powerful, it could take you from New York to Los Angeles in just under half an hour. These supersonic winds have been detected on a variety of exoplanets, from gas giants to rocky worlds. They're particularly prevalent on so-called hot Jupiters, enormous gas planets that orbit dangerously close to their stars. The extreme temperatures on these planets create intense atmospheric pressure differences, driving these incredible winds. But what does this mean for the possibility of life? Well, it's not exactly promising. Such extreme wind conditions could create a hostile environment for any potential life forms. The rapid winds might disrupt stable climates, cause extreme weather, and erode surface features. However, these supersonic winds also provide us with a unique opportunity to learn more about these distant worlds. By studying these winds, we can gain insights into the exoplanet's atmospheric compositions, weather patterns, and even their internal structures. Despite the challenges they present for habitability, these supersonic winds are a fascinating aspect of exoplanet atmospheres. They remind us of the incredible diversity of the universe and the endless possibilities it holds. These supersonic winds certainly blow us away with their intriguing presence in exoplanet atmospheres. At number 4, we have the perplexing absence of atmospheres in some exoplanets. A common expectation when observing exoplanets is the presence of an atmosphere. After all, an atmosphere is a key component in the life-sustaining formula that we know works. It's right here on Earth. However, the universe, in its infinite complexity, often surprises us. In some instances, when telescopes point their gazes towards distant stars, hoping to catch a glimpse of an exoplanet's atmospheric composition, they find nothing. A void where an atmosphere was anticipated. It's a puzzle that leaves scientists scratching their heads. How can an exoplanet, particularly one that's within the habitable zone of its star, lack an atmosphere? There are several theories. Perhaps violent solar winds from the exoplanet's star stripped it away. Maybe an asteroid impact blew it into space. Or it could be that the planet's core just isn't strong enough to hold onto an atmosphere. Whatever the reason, these instances challenge our understanding of what makes a planet habitable and force us to reconsider our expectations. But as strange as these cases are, they provide an opportunity. Each atmospheric absence is a piece in the larger puzzle of the universe. They prompt us to ask new questions, explore different theories, and push the boundaries of our knowledge. The absence of atmospheres in these cases certainly adds to the intrigue of our cosmic investigations. Coming in at number 3, we have the enigma of glass rain in some exoplanet atmospheres. That's right, you heard it correctly, glass rain. Now let's delve into this mysterious phenomenon. Our journey to understanding this begins with the detection of silicate particles in the atmospheres of some of these distant worlds. Silicates, for those who don't know, are the building blocks of most rocks on Earth, including quartz and yes, even glass. In the extreme heat of these exoplanets, silicates can vaporize, turning into tiny particles that float around in the atmosphere. But what happens when these particles encounter cooler temperatures? Well, they condense much like water vapor does on Earth, forming clouds. But here's where things take an otherworldly twist. Unlike the gentle water droplets that fall from our earthly clouds, these silicate clouds do something quite different. They harden and turn into tiny shards of glass, and then they rain down. Yes, it literally rains glass on these exoplanets. Imagine a downpour of glittering shards, a storm of brilliance and danger, a spectacle both beautiful and terrifying. This is not a scene from a science fiction novel, but a real phenomenon happening on worlds far beyond our own solar system. This glass rain certainly adds a unique sparkle to the mysteries of exoplanet atmospheres, and it serves as a reminder that the universe is full of wonders that stretch the limits of our imagination. Almost at the top, at number 2, we have the dominance of carbon dioxide in some exoplanet atmospheres. These unusual spheres of gas circling distant stars are not just filled with the familiar nitrogen, oxygen, and argon that we're used to here on Earth. No, some of these exoplanets have atmospheres dominated by carbon dioxide. Imagine a world where the air we breathe is replaced by this colorless, odorless gas. It's a chilling thought, isn't it? For us Earthlings, high levels of carbon dioxide could be catastrophic. It's a heavy gas that in large quantities can cause a number of health issues. But for potential extraterrestrial life forms, could it be their oxygen? Could there be organisms that thrive on carbon dioxide? However, the dominance of carbon dioxide also presents a major challenge, the greenhouse effect. Carbon dioxide traps heat, causing a planet's temperature to rise. On a world dominated by this gas, the temperature could potentially skyrocket to levels that are inhospitable for life as we know it. Yet the universe is a place of endless possibilities. The existence of these carbon dioxide-dominated atmospheres could suggest the presence of life forms with radically different biochemistries than our own. Or they could be a testament to the destructive power of a runaway greenhouse effect. In the grand scheme of things, these carbon dioxide-dominated atmospheres are a stark reminder of the diversity of exoplanets. Each one is a unique, tantalizing mystery waiting to be solved. The dominance of carbon dioxide certainly adds a suffocating twist to the mysteries of exoplanet atmospheres. And finally, at number 1, we have the most intriguing of them all, the potential indicators of alien life in some exoplanet atmospheres. As we delve into the cosmos, the question of are we alone continues to echo in our minds. The answer may well lie in the gaseous shrouds encircling distant exoplanets. Two gases in particular, methane and oxygen, have piqued the interest of astronomers and astrobiologists alike. Methane, a simple organic compound composed of carbon and hydrogen, is a common byproduct of biological processes here on Earth. It could be a telltale sign of alien life if detected in the atmosphere of an exoplanet. However, methane can also be produced by geological activity, so its presence alone doesn't guarantee extraterrestrial life. Oxygen, on the other hand, is a vital ingredient for life as we know it. On Earth, oxygen is continuously regenerated by photosynthesizing organisms, making it a sustainable element in our atmosphere. If we find significant levels of oxygen in an exoplanet's atmosphere, it could suggest the existence of similar life-sustaining processes. However, caution is the watchword. The detection of these gases, while promising, is not definitive proof of life. There are various non-biological processes that can also produce them. Hence, scientists are aiming for a more comprehensive understanding of these planetary atmospheres, looking for a combination of gases that could indicate a balanced, life-sustaining ecosystem. The potential indicators of alien life certainly top the list of mysteries, making exoplanet atmospheres a fascinating field of study. And there you have it, the top 10 mysteries of exoplanet atmospheres. These enigmas, from the baffling absence of water vapor to the dominance of carbon dioxide, the exotic clouds and unusual chemical compositions, they all form an intricate cosmic puzzle. Each piece, whether it's the temperature extremes, the presence of precious metals, or the supersonic winds, adds another layer of complexity. The seemingly empty atmospheres and the mind-bending phenomenon of glass rain, they all challenge our understanding of what we believe to be universal truths. And perhaps most intriguing of all are the potential indicators of alien life. These signs, subtle yet profound, hint at the possibility of life beyond our own planet. As we continue to explore the cosmos, the mysteries of exoplanet atmospheres will continue to captivate us, pushing the boundaries of our understanding and imagination. These endless mysteries remind us that we still have so much to learn about the universe, and each discovery only leads to more questions. And there lies our journey through the mystifying world of exoplanet atmospheres. If you've enjoyed this cosmic journey and learned something new, then we invite you to leave a like on this video. Your support helps us continue exploring these fascinating topics. We'd love to hear your thoughts on these mysteries. Do you have a theory about the exotic clouds or the supersonic winds, or perhaps the indicators of alien life? Share your opinions in the comments section below and let's unravel this cosmic puzzle together. Don't forget to subscribe and press the bell icon to stay updated with our latest explorations. We've got a universe full of wonders to discuss, and we'd love for you to join us on this voyage of discovery. Share this video with your friends and family, and let's spread the curiosity. After all, the universe is a mystery we all share. So until next time, keep looking up and keep questioning.